rational exponents. So these are very similar. So section 10.4, rational exponents. So this is very similar to what we've done in the previous sections where we looked at exponents. And then it'll turn out that this will give us some additional insight on how to do these radical problems, because they will be the same as this idea of a rational exponent. So first off, let's recall how we define integer exponents. So I will define a to the power 1 as a. I'll define a to the power n as a times a to the power n minus 1 for any natural number n exponent. That gives us a definition for all of the natural number exponents. Next, let's define a to the 0 as equal to 1 if a is not 0. And let's define 0 to the n as 0 if n is some natural number. Next, let's define a to the negative n as 1 over a to the n, so long as I'm not dividing by 0, so long as a is not 0, and n is some natural number. And so this gives us a definition now for all the integer exponents. Next, let's define a to the power 1 over n. Well, a to the power 1 over n is the nth root of a if a is greater than 0, or if n is a odd natural number. A to the power 1 over n is 0 if a is 0. A to the power 1 over n is undefined if a is negative and if n is an even natural number. Now, let's try to define a to some rational exponent. So let m over n be in Low's terms, where m is some integer and n is some natural number. Then let us define a to the power m over n as equal to a to the m, all to the power 1 over n. Or, if you like, let's define it as a to the 1 over n, all raised to the power m. Let's be a little bit more specific what we mean by this. Because, you know, here when I say this, I actually say, well, it's equal to this so long as everything that I've written here is defined, so long as all this makes sense. So let me actually specify out what I mean by that. A to the power 1 over n is equal to the nth root of a to the m, or, if you so like, it is the nth power of the nth root of a. And this is so long as, well, everything is defined, a is greater than 0 and n is a, or, it's not an and, that's a typo, that's an or. If a is greater than 0, or if n is a odd natural number. So it should look like what it is here. That's an or. It's equal to 0 if a is 0. And it's undefined if, well, I'm trying to take the nth root of, even nth root of a negative number. So it's undefined if a is less than 0 and if n is a even number. We define a to the negative m over n as just 1 over a to the m over n. So let's do some examples. Let's say on page 424, let's do problem number 2. In exercises 1 through 20, write the expression in radical form and simplify. So all this says here is that these exponents are just another, these rational exponents are just another notation for radicals. And so the 64 to the power 1/2 is the same as the square root of 64, but the square root of 64 is 8. And so 64 to the power 1/2 is 8. Then we do problem number 4. 27 to the power 2/3. Well, I can do it one of two ways. I can either say that, so notice I gave two different definitions. So let's do this first definition. So 27 to the power 2/3 is the same as the cube root of 27 squared. Well, 27 squared is 729, and the cube root of 729 is 9. So notice that, you know, 27 squared is not such a nice number, and the cube root of this is, again, you know, because it's a big number, it's not so easy. But if we do it the other way, it actually turns out to be easier. So it said that it was also equal to the nth root of a all to the power m. So I could just take the cube root of 27 and then square it. Well, the cube root of 27 is 3, and 3 squared is 9. So notice that we're dealing with much smaller numbers. So if you're dealing with numbers, it's always easiest to take the root first and then the exponent, rather than taking the exponent, making your radicand gigantic, and then taking a root of that. So if you're talking about where the case where a is a number, then it's always easiest to use the second definition, where you take the root first and then the exponent. Okay, so let's do problem number 27. Oh, I'm sorry, problem number 8. Negative 27 to the power 1/3. So this is the same as taking the cube root of 27 and then negating it. So it's a negative cube root of 27. The cube root of 27 is 3, so my answer is a negative 3. Let me do problem number 10. So I have a negative 27 to the power 2/3. So let's take the cube root first. And so the cube root of negative 27, negative 3, and then square it. Negative 3 squared is 9. Let me do problem number 14. 625 to the power negative 3/4. And so I have a negative exponent. Since I have a negative exponent, that says take the reciprocal. So let's take the reciprocal of 625 to the 3/4. Then let's take the cube root. I'm sorry, fourth root of 625, and then raise that to the power 3. The fourth root of 625 is 5. 5 cubed is 125. Therefore, 625 to the power negative 3/4 is just 1 over 125. And that's your answer. Let me do problem number 18, negative 128 to the power 4/7. So let's take the 7th root first. So the 7th root of negative 128, negative 2. And now let's raise that negative 2 to the power 4. Negative 2 to the power 4. Negative 2 times negative 2, 4 times negative 2, negative 8 times negative 2, 16. So my answer is a positive 16. Let's look at, as an example, negative 128 to the power negative 4/7. So first, deal with the negative exponent. And so let's take the reciprocal of negative 128 to the power 4/7. Now let's take the 7th root. So I have 1 over the 7th root of negative 128 to the 4th. The 7th root of negative 128 is a negative 2. And then let's raise the negative 2. There's a typo here. They should say negative 2. Let's raise the negative 2 to the power 4, which is a positive 16. So my answer is 1 over 16. Let me do problem number 22. In exercises 21 through 44, simplify the expression and write the result in exponential form without any radical in the denominator. Okay. 27y to the power negative 1/3. Let's deal with the negative exponent. So let's take the reciprocal. So 1 over the 27y to the power 1/3. Let's raise each of these quantities to the power 1/3. So it's 1 over 27 to 1/3, y to the 1/3. The cube root of 27 is 3. Let's multiply and divide by y to the 2/3 so that the exponent in the bottom will not contain a fraction. So I get y to the 2/3 over 3y. Let me do problem number 26. So I have 25y to the 5th, y squared over 16x y squared to 1/2. Let me cancel some of this. Notice that x to the 5th divided by x is x to the 4th, and the y squares cancel. And so now, let us raise each of these to the power 1/2. So the square root of 25 is 5. The square root of 16 is 4. The square root of x to the 4th, well, I can write this square root here. I can raise this to the power 1/2. So x to the 4 times to the power 1/2. Multiply the 4 times 1/2 to get x to the power 2. And so this simplifies to 5x squared over 4. Let me do problem number 36. X to the power 8/3, y to the power 7/3 over y to the power negative 2/3 times x to the power 2/3. So let's simplify this. First, let's deal with this negative exponent. So let's interchange it from the denominator up to the numerator. So I get x to the 8/3, y to the 2/3, brought up from the denominator, times y to the 7/3 over x to the 2/3. Well, x to the 8/3 divided by x to the 2/3. 8/3 minus 2/3 is 6/3. Y to the 2/3 times y to the 7/3. So as I multiply and I'll add exponents. 2/3 plus 7/3, 9/3. Well, 6 divided by 3 is 2. 9 divided by 3 is 3. And so this simplifies to x squared y cubed. 40. a x to the power a plus b, a minus b, a x to the power b plus c, b minus c, a x to the power c plus a, c minus a. So let's raise each of these to the power a minus b. So I have a base a to the power, well, a minus b. I have x to the power a plus b to the power a minus b. So let's multiply exponents. A plus b times a minus b. This is, again, a special product formula. It's a product, the sum and difference of the two terms. And so it's equal to the difference of their squares, a squared minus b squared. Again, a to the power b minus c, x to the power, well, again, these are the product of the sum and difference of two terms. And so the product will equal the difference of their squares, b squared minus c squared. Lastly, we have the same thing, a to the power c minus a, x to the power. Well, this last product is the product of the sum and difference of two terms, which is the equal difference of their squares, c squared minus a squared. So I have the same base a. I add exponents. The b's cancel. The c's cancel. The a's cancel. So I just get a to 0. Let's look at the x's. Well, I have the same base x. And so I'll add exponents. Negative b squared plus b squared cancel. Negative c squared plus c squared cancel. A squared minus b squared also cancels. So again, you have x is 0. Well, assuming a and x are not 0, then this is equal to 1 times 1, which is 1. And that's your answer. Let me do problem number 46. In exercises 45 through 69, simplify the radical expression and write the answer in exponential form. Assume that all variables represent positive numbers. Okay, so let's do this. The cube root is 7 over 2. Well, that's just 7 over 2 to the power 1/3. 52. The fourth root is 16, x squared y over the fourth root of 2, x cubed y squared, y cubed. Well, this is the same as the fourth root of 16 x squared y over 2 x cubed y cubed. I can divide 16 divided by 2 is 8. X cubed divided by x squared is x. Y cubed divided by y is y squared. And so I can raise each of these to the power 1/4. So this is x to the power 1/4, x to the power 1/4, y squared to the power 1/4, so that's y to the 2/4, which I can write as 1/2. So my final answer is 8 to the 1/4 over x to the 1/4, y to the 1/2. Let me do problem number 62. Square roots of 4x squared minus 12x plus 9. Again, this is a special product formula. This is just 2x minus 3 quantity squared. The square gets rid of the square root. And so it's just 2x minus 3. And again, since x is positive, well, I'll assume that they say assume that all variables represent positive numbers. I'm assuming that 2x minus 3 is positive. Problem number 64. The square root of 16, x to the 4 minus 8x squared plus 1. Well, it's the same thing as above. It's a special, this by a special product formula. This is a perfect square trinomial. This is just 4x squared minus 1 quantity squared. The square root of 16, x to the 4 is 4x squared. The square root of 1 is 1. And so the square gets rid of the square root, and so I just get 4x squared minus 1. Lastly, the cube root of 27 x cubed minus 27 x squared plus 9x minus 1. Well, this is a perfect cube. This is just equal to the cube root of 3x minus 1 quantity cubed. The cube root gets rid of the cube root, so 3x minus 1. And lastly, oh, I guess I have two more. An example. Suppose I have 81 x to the 8 over 16 y to the negative 3 to the power 1/4 to the power negative 3. So let's raise everything inside to the power 1/4. So I get 81 to the 1/4. 8 times 8 divided by 4 is 2. 16 to the power 1/4. Q to the power negative 3 times 1/4 is negative 3/4. Let me simplify this somewhat. The fourth root of 81 is 3. The fourth root of 16 is 2. Let me raise everything to the power negative 3. So I get 3 to the negative 3. P 2 times negative 3 is negative 6. The sixth root of 16, the fourth root of 16 is 2. And so I get 2 to the negative 3. Q to the negative 3/4 times negative 3 is a positive 9/4. Lastly, let me bring down interchange the exponents if they're negative. So this 3 cubed comes to the bottom. This 2 cubed comes to the top. The p to the 6 go to the bottom. 2 cubed is 8. 3 cubed is 27. And then I have everything else. P to the 6, q to the 9/4. And lastly, 4x squared y to the 1/3, 2x y squared to the 1/3, x y squared to the 2/3. Okay, so I have the same base. I have the same exponent. So let's multiply bases. So I have 4 times 2 is 8. X squared times x is x cubed. Y times y squared is y cubed to the power 1/3. And so let's raise everything inside the parentheses to the 1/3. So we get 8 to the 1/3, x cubed to the 1/3, y cubed to the 1/3. Let's raise everything to the power 2/3, x to the power 2/3, y to the power, well, 2 times 2/3 is 4/3. And last, the cube root of 8 is 2. X to the 3/3 divided by x to the 2/3. Well, 3/3 minus 2/3 is 1/3. Y to the 4/3 divided by y to the 3/3. 4/3 minus 3/3 is 1/3. So I get 2x to the 1/3 over y to the 2/3. And that finishes off section 10.4. Any questions about that? Okay, so I guess that is it for today. And I'll see you on Monday for the exam. Okay, bye-bye. I guess I'll delete people. Bye.